Let's start with the motor driving interfacing. As if all of you are aware about the motor, so the motor is basically a device used to convert electrical energy into a mechanical energy. The reverse of this would be the conversion of mechanical energy into electrical energy, and it is done by electric generator. So, a motor is very useful in robotics and embedded system to give movement and designing control system. In normal motoring mode, most electric motor operate through the interaction between an electric motor magnetic field and winding currents to generate force within the motor. In certain applications such as the transportation industry, with traction motor, electric motors can operate in both motoring and generating or braking modes to also produce electrical energy from mechanical energy. So basically there are two types of motor. One is AC motor and one is DC motor. So as all of you are aware about what is AC and DC motor, let me give you the small description of AC motor. AC motor is an electric motor driven by an alternating current. The AC motor commonly consists of two basic parts: an outside stationary starter having coil supplied with alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft producing a second rotating magnetic field. The rotor magnetic field may be produced by permanent magnets, reluctance, saliency, or DC or AC electric winding. Less commonly, linear AC motor operates on similar principle as rotating motor, but have their stationary and moving parts arranged in a straight line configuration, producing linear motion instead of rotation. Next is the DC motor. So a DC motor is any of the class of electrical machine that converts direct current electrical power into a mechanical power. The most common types rely on the forces produced by a magnetic field. Nearly all types of DC motors have some internal mechanism, either electromechanical or electronics, to periodically change the direction of a current flow in part of the motor. Most types produce rotatory motion. A linear motor directly produces force and the motion in a straight line. DC motors were the first type widely used since they could be powered from existing direct current lightning power distribution system. A DC motor's speed can be controlled over a wide range. Next we are see what are the types of DC motor which we used in robotics. So basically in robotics we are using three types of motor. One is stepper motor, then is servo motor, and then is geared motor. So let's see about the stepper motor. A stepper motor which divides its full rotation into a large number of steps is called a stepper motor. These steps help in precise step-by-step movement of the rotor, giving precise control over movement. The shaft of stepper motor has permanent magnet attached to it. The rotor is surrounded by a series of coils which can be turned on and off. Magnetic field change cause the rotor to move. As the movement is controlled by turning coil on or off, it is easier to program the movements of stepper motor using microcontroller. These motors are also called open loop systems and do not have any feedback mechanism. These have very simple design and are often less reliable. Such motors are used in variety of devices like linear actuators, printers, etc. Next is servo motor. Servo motor that allows more precise control of position, velocity or torque using feedback loop. This feedback loop help in stability analysis and give better control over movement. These are also called closed loop system. These motors cannot rotate continuously and hence cannot be used for driving wheels. These motors used have a 90 to 180 degree movement. Servo motors are normally used in machines, tools and automation robots. Programming these motors are more complex, also the design is more complex. These are more reliable than stepper motor. Next we have a geared DC motor. A geared motor are motors with an integrated gearbox. The function of gearbox is to increase torque, generating capacity of the motor, reducing its output speed. The geared motor have a variety of application. Some of its uses are in the wheelchair, stair wheels, etc. So let's come to the basic motor specification. So in the basic motor specification, first of all we have to check the operating voltage, the current drawn by the first of all we have to check the operating voltage, the current drawn by the motor, the torque of the motor, and the speed or rotation of the motor. So basically the operating voltage is a nominal voltage that recommends for the operation of motor. Let's suppose most small DC motors are designed for 1.5 volt to 12 volt operation. So with the majority in the 3 to 6 volt range, larger DC motor designed for heavy duty application usually requires 12 to 24 volt, with some needing upward of 90 volts. Often but not always, the higher the voltage, the more powerful the motor. So the most motors can be run at operating voltage higher or lower than the specified rating. So there are 2 points which you have to remember is lower voltages reduce torque and speed, and higher voltages increase torque and speed. So avoid applying excessive high voltage to motors, or else it could overheat and burn out. So next we have the current draw. The amount of current is specified in milliamps or amps, means ampere, that the motor required to produce a certain amount of torque. So the motors consume different amount of current depending upon how they are operated. So in case if there is no load on the motor, so a motor that does not have anything attached to its shaft is not doing any work and is said to be free running. No load current tend to be a very low. If in case the motor is having a load, as the motor does work, its load and current draw increases. Manufacturers rate the current draw under load using different standards. Third, when it is stalled, means when the DC motor shaft stops rotating, it stalls and draws as much as current will flow through the winding. So this specification is useful for worst case scenario. Then the last is shorted, means maximum current flowing into the motor when the coils are shorted out. The motors will not run and like any short circuit. If operated in this way for any length of time, serious damage can result to the other system on the robot. Next we have the torque. So the way the strength of the motors is measured. It is typically calculated by attaching a lever to the end of the motor shaft, a weight or gauge on the end of that lever. The length of the lever usually depends upon the unit of measurement given for the weight. Example, suppose or we want to measure in the metric measurement. So in metric measurement use Newton meter, means Newton meter. So Newton meter or kilogram force meter means kgfm, or sometimes in gram centimeter. So in this way the torque is measured. So standard measurements use ounce or inches. So next we have the speed. Speed of the motor indicates how fast its shaft is turning. The speed of a motor actually without a gearbox is spin at 3000 to over 12,000 rpm. So with a gearbox the speed can vary from 1 rpm to so on. Stepper motors are not rated in rpm but pulse per second. So make sure whenever you are going to buy a stepper motor, you have a pulse rate per second. The speed of the stepper motor is a function of a number of steps required to make one full revolution times the number of steps applied to the motor each second. Typical values are 200 or 300 pulse per second. It is written on the stepper motor always like 200 or 300 or any other value in pps, means pulse per second. Now next we are going to learn about the H bridge.